Okay, we're going to go ahead and get started. Good afternoon, good morning, wherever you're listening in from. My name is Ben Follett, and I'm the Product Marketing Manager for RISA. And today, I'll be your host for our webinar, What's New in the RISA Building System. So really today, we're going to focus a lot on the newest features that are coming up in all the releases of RISA. So we've got, advance to the next slide here. Before we jump into that, just want to make mention, we have some audio. If you have any issues with the audio, you can use the phone call or the computer audio. You can switch back and forth. You can use the dial-in number and just make sure you put in the appropriate meeting ID and participant ID. Additionally, if you have any questions, you'll see in the bottom of the Zoom bar, there's a Q&A button. We have a few engineers that will be monitoring that Q&A, and they will be able to answer your questions during the presentation. If there are anything left over or if there's any additional questions, we can take some at the end depending on how long the presentation is, but we want to make sure that we do get some questions answered during the bulk of the presentation. So as I mentioned, what we're looking to and talking about are new releases of our core software. And so RISA 3D, RISA Floor, RISA Foundation, and RISAConnection. RISA 3D will be version 19, RISA Floor version 15, RISA Foundation version 13, and then we have a small update to RISAConnection version 12.01. And so we'll be talking a lot about the new features in all of these and kind of working through some different models to show you kind of all the main features. For those of you that are current users, once the new features are released, so we're looking to release in the next few days or so, hopefully the next week or so, you will be able to access the customer portal and pull the most recent download from the customer portal. So you can just visit the customer portal, click on the download section, and then you can pull those downloads for whatever software package that you own and whatever software package you're looking for that most recent release. Now let's go ahead and just jump right into it, jump right into the new features. And so to start, obviously, with kind of our breadwinner, our main program, RISA 3D, we have a lot of new material code updates, some which we'll show live, some which we'll just talk about here in a PowerPoint. So new cold form steel wall design, a really highly requested feature. So we really listened to our customers and added cold form steel wall design in this case. Additionally, we've added support for ACI 31819, so the new concrete code, both in RISA 3D, and we'll see that in RISA Floor and RISA Foundation as well. We've also added support for the seismic provisions for steel from AISC 341 and 35816, so those new provisions as well have been added into RISA 3D. From a modeling and analysis standpoint, we've added a few really nice features. One that I'm really excited about, orthotropic plates. Orthotropic plates giving you the ability to get different stiffness in different directions for plates. We've also worked really closely with the people over at Simpson Strong Tie to add the yield link moment connections. So we'll be able to spec those out in our kind of pinned releases or end releases conditions in a RISA 3D model. And then finally, we've also added some internal force estimation tool elements for solids. Additionally, we've also expanded load categories, so you can now add up to 100 other load categories. That was a really highly requested feature from people. And we've also added the scaling factor for basic load cases. For RISA Floor, a lot of the same material, as long as a lot of the same material code updates also apply. So cold form steel wall design is in RISA Floor. That ACI 318 concrete code is also in RISA Floor. We've also added design for back-to-back CFS profiles. So previously we supported those profiles but didn't support the design. The design is also supported in RISA 3D and has been for some time, and so we've added that now into RISA Floor. And then another big improvement, again, in this kind of spirit of cooperation, working with other industries and working just like we did with the Simpson people. We're working with the Steel Joist Institute to add composite steel joist design. And this is the first time that composite steel joists have been actually modeled or added in any kind of general finite element analysis and design tool. And so we'll show that too as well. And then another really highly requested feature, the ability to exclude results per selection. That is an enhanced control of results in both RISA Floor and RISA Foundation. So as I mentioned, RISA Foundation, again, ACI 31819 concrete code updates. We did add some improvements for seismicity, specifically the ability to add these seismic factors in the load combination generator, so to add your redundancies, your omega factors, your vertical distribution factors, but also being able to pull the RSA results, those response spectra analysis results, from RISA 3D into a RISA Foundation model, which is something you couldn't do before. So now you can bring those that information over from that dynamic analysis to go ahead and look at your design of foundations. We also, as I mentioned, expanded the load categories to use 100 other load categories, and then also added the exclusion of results per selection. So to be able to kind of really just kind of dial into the results that you want to look at based on the selection that you have. Finally, for RISAConnection, some of these are version 12 features, but we're kind of rolling them all together. We've added skewed sheared connections, both shear tabs on column beam and girder beam connections. And then the big one that we're really excited about is custom anchor bolt layouts. Again, another one of those really highly requested features, being able to customize the anchor bolt layouts, add custom numbers of anchor bolts, custom spacings and locations for anchor bolts to be able to really hone in on those conditions that aren't, a very standard, column on a square footing in the middle of a building. We need to have those custom anchor bolt layouts so that you can do the job that you need to do. So as we jump into some of these features here, we'll talk a little bit in kind of a PowerPoint about some of the features with concrete and steel, and won't necessarily show those live. So as far as ACI 318.19, the concrete code goes, there are a few changes that have been made since the 14 edition, so the 2014 edition. The first is the expansion of applications for high strength rebar. And we have the references here, so you can, if you have the manual, you can go ahead and look at these references. But really, this expansion includes a strength reduction factor, the minimum and maximum flexural reinforcement limits for that high strength rebar, and then also the axial compressive strength of the column has changed. One of the other big changes is the shear contribution of concrete. We're all really familiar with the kind of standard old school V sub C kind of equation for that shear of concrete. Now you can see in just the table that I have listed below here, it really depends on a criteria of your area of steel, shear steel, and then you use the corresponding VC equation accordingly. Additionally, we have an interaction of biaxial forces, also an allowable compressive strength of concrete piles change, and then finally a slab reinforcement requirements for critical sections and punching shear change. And so all of these changes are included, again, both in RISA 3D, RISA Foundation, as well as RISA Floor. And so the next part is AISC 341 and 358.16, the seismic provisions for structural steel buildings. So a few of the changes from the previous code include the calculation of limiting width to thickness ratios in table D 1.1, the calculation of bracing requirements for moderate ductility members or high ductility members. We've added the calculation of the sum of expected flexural strength of the beams at the plastic hinge location for those special moment frames. Also, the calculation of the required shear strength of connections, the calculation of expected compressive strength for brace frames, and then ultimately kind of this implementation and kind of full acceptance of the ASTM A1085 kind of specification for HSS shapes, now included both in the AISC 360, but also in the AISC 341 and 358 conditions. Again, like I mentioned, one of the ones that I'm really excited about is orthotropic plates. So giving the user now the ability to define a plate methodology for a general material. So in this case, if we looked at a general steel material, we could define that plate methodology as orthotropic rather than standard isotropic. Isotropic meaning the same interaction or the same stiffness, the same load transfer in both directions. This allows us to manipulate the plate such that the stiffness differs in the longitudinal and the transverse directions. And so we can define this, if we look down here on the right-hand side here, we can define this by changing the values of the modulus of elasticity in either direction, either the local Y or local X direction, and also the shear modulus as well. And so we can change these different properties to simulate kind of the distribution that we want. In this case, we always want to utilize real values where necessary. So whether they're computed values or calculated values, you want to utilize this as real values as you can to get real distribution and real interaction. And then some of the uses for orthotropy, metal decking is one, and this is kind of what I'm simulating in this picture here. Just as I model plates, I gave it a metal deck thickness, so that actual thickness of the deck itself, the material, not the ribbed thickness. And then we can see here kept the modulus elasticity kind of strong in one direction, the direction I wanted the load transfer, and then very weak, almost zero in the other direction. And so we get this kind of pretty close to true one-way distribution for plated structures with loads applied to the surfaces. We can also use those for CLT and also for rib slabs. Now, one of the biggest one that people have been asking for is we've gotten back integration into the RISA building suite. And so integration not only with our own products, but also with other outside vendors. And so the RISA building suite, RISA 2D, 3D floor, foundation, and connection, as well as RISA section, all now integrate together and will integrate together with version 19 of RISA 3D, 15 of RISA Floor, 13 of RISA Foundation, and 12.01 of RISA Connection. And so we'll be able to do that integration. The next is also integration with the BIM software suite. So integration with Autodesk Revit 2021, as well as Tekla Structures 2020. We also have integration through the SIS2 translator with other programs like SDS2. And then finally, other design software. So being able to integrate with your STAAD Pro files and also your TNX Tower files as well. And so all of that integration is available in these latest set of releases. And we'll go ahead and see kind of the process integration work live here when we jump into our live demo, which brings us actually into our live demo. So I'm going to go ahead and switch over and open up our RISA Floor model. So let's just go ahead and jump into RISA Floor real quick here. So we'll open up RISA Floor version 15. And in this particular case, I'm going to go ahead and we're going to go ahead and use this kind of very simple structure. So we're using this very simple structure here. And to start, if we go ahead and look at this structure, the full model in 3D here, you can see we've got some joists on the roof. I've got some concrete shear walls. On the right-hand side here in this kind of navy bluish color, these are our cold form seal walls. And so we have some gravity and lateral cold form seal walls as well. And so once we start here, let's go ahead and go to our floor plan 1 and let's look a little bit about our cold form steel walls. So the first thing I'm going to do is look at our wall design rules. So typically, we have these very specific wall design rules for each individual material. And so if we look at CFS wall studs here, we can see that we can define our top plate, our sill plate, our stud spacing, and then our header. So that information for kind of the bulk of the wall. And then on the fasteners tab, just like we have similar for wood wall fasteners, we define the type of wall. We're only using segmented in this case. We can choose the sheathing material, so fiberboard, gypsum, steel sheathing, or a wood sheathing. We can choose the schedule and the panel thickness to be designed from the minimum to maximum thickness, our fasteners and spacing, and then finally the cords that we're using in the design here. Now we can see that we can, in this particular case, if I go ahead and look at my studs, we're using these CS studs from the SSMA database. We could also choose the AISI database if we wanted to, but I'm going to go ahead and actually use back-to-back studs. In this particular case, we can use those studs in the design of that wall if we want. And that's obviously the kind of this combination of two of the newest features in RISA Floor. Now you can see here that we've got some walls defined as gravity and lateral, just like any of our other walls. If we go ahead and open up our draw modify walls, we can go ahead and click CFS just like you would any other wall panel, and we can choose if this is a lateral or gravity wall to be exchanged with RISA 3D to do the lateral analysis and loading when we get to that point. I can also go ahead and look at, let's see, if I open up this wall here, we've got, just the same interface from a wall panel editor's perspective as we do for other wall panels. And so we can add openings, which adds our lintel, which gives us our regions so that we could design those individual regions if they're applicable. In this case, we have a segmented design method, so we're not going to get design of these regions above the opening, but we will get design of the rest of the regions per that segmented design method. Now, the other really new feature, and we'll go ahead and look at more results for the cold form steel walls once we run the design and also look at those results in RISA 3D. The other big new feature in RISA Floor, other than the concrete, is our ability to design with composite steel joists. And so in this case, this part of the model here is going to be my composite steel joist part of the model. And so we're going to actually go ahead and model and look at kind of the provisions of that. And so if we go ahead really quickly to we already have our wide flanges modeled, so let's go ahead and look at our shape sizes so we can see our wide flanges that are kind of framing out this floor. We can also go ahead and look at our deck definitions. So if we look at our deck definitions, in this case, we're looking at our composite deck. So this a same or similar composite deck for regular steel, hot rolled steel we're using for composite or composite steel joists. And so we can see here we're using kind of a standard stud diameter specified by the SGI of 3/4 of an inch, and also using our choice of database from Verco or Volcraft in this case. And so I'm going to go ahead now into our generate infill beams, and I'm going to select steel product. And just like I would add a steel product for K-series joist or DLH or LH series joist, or maybe I wanted to specify a joist girder, I'm going to go ahead and specify our CJ joist. Now these CJ joists are, strong axis orientation bending always. They're also pinned. And so I'm going to go ahead and then choose that I want these to be input in the, let's say, horizontal direction. And I can go ahead and choose either an exact spacing or an equal spacing not to exceed, let's say equal spacing not to exceed 7 feet. And I'm just going to go ahead and start to click in the bays here. So we're going to go ahead and add those based on the spacing that we selected. Now, ultimately, we need to make sure that our diaphragm and our deck is in the correct direction. So I'm going to go ahead and look at our deck as applied. And so we can see here that I've made a modification to this deck, whereas it's going in the Z direction here, parallel to the Z direction up here, we have it parallel to the X direction down in this case. So we're going to get appropriate distribution of those particular forces for that model. The next thing is, if we look at our area load definitions, again, we're just doing a typical office area load in this case. So if I select back here and we look at our load with the default as well, I've got a typical office area load, but I do have some additional loads as well. This is obviously very typical of RISA Floor, regardless if you're doing composite steel joists or not. But I have we have a public load here, and then maybe a heavy kind of storage load as well. And so if we go ahead now and look at those loads, we can also add additional loads. So if I look maybe at our live loading here, I do have some live loads. Let's go ahead and turn off our area loads. I do have some live loads applied to some of the CJ series joists. And so maybe in addition to this point load, maybe we wanted to add a live load of, 100 pounds a linear foot. And maybe it's going to be from center line to center line here. Maybe this is going to be a partition that's hung in this particular part of the model. And so we can go ahead and add that as well. So when we have that all added in there, we can go ahead and make sure that we have our load combinations set up. So I already have some load combinations previously established. So we've got our design combinations and our serviceability combinations. The code required for composite steel joists in this case, if we look at our codes here, is an LRFD code. So we are going to do an LRFD code design. And so in that case, we'll go ahead and make sure that we have our LRFD combinations in this case. We can, as of right now, do beam vibrations for hot rolled steel as well as joist. We have not yet implemented steel composite joist vibrations yet. That's something that we'll continue to work with the SJI on to do composite steel joist vibrations. They have some design guides that they've written and are continuing to upgrade, and we'll add that CJ vibration stuff as we continue to work with them for those improvements. And so with the model, with everything generated here, I'm going to go ahead and run the analysis. So if you're not familiar with RISA Floor, RISA Floor is doing a design and optimization. So it's taking that CJ series joist size, and it's going to go ahead and find that size based on the criteria in the model. And so now that we've gone ahead, we can go ahead and start to look at some of our results. And so the first thing I'm going to do is let's go ahead and open up some of our wall design results. So let's say wall results. And so we can look at our CFS wall results, for instance, so we can see just the basic results for the stud spacing, the axial check. Remember, we're only doing that gravity-only analysis in RISA Floor, so we see that axial wall check. We can also look at a detailed analysis. So, this is just the basic detailed output for maybe a gravity wall here in RISA Floor. We'll obviously look at this in a little bit more detail in RISA 3D when we look at some of the output for those lateral walls. We can also go ahead and look at the results for our composite steel wall, our composite steel joist. So before I do that though, I'm going to go ahead and choose to exclude the results for only these joists. Basically, I just want to see these joists in my table. So I'm going to go ahead and unselect everything, and then I could use a selection by line, or in this case, I'm going to do a select elements by kind of property and choose beams here and say shape CJ. So find me all my CJs, there they are, and then I'll choose exclude. And so when I exclude, it says you've requested results to be listed in the browsers, basically in the spreadsheets for only the items that you've selected. Is that what you want? Yep, in this case, it surely is. So I can go ahead and look at our code check, or not our code checks, sorry about that. We can go ahead and look at our design results for our steel products. You know, we'll only see these results when we look at these tables. And so in this particular case, we have our table, our size. So we have our uniform dead load, our uniform live load on the joist, and then our uniform total load, as well as our max and min start and end reactions. And so if we zoom in here, let's zoom into the joist here, we can see the joist size as it's listed. Again, this is from working very specifically, very closely with the Steel Joist Institute. This joist size is a feature of the size of the joist or the depth of the joist. That's that first note there, so 20. CJ for composite steel joist. Then we have this next number, 1145 in this case. This is the total factored load, so this is why we're using LRFD. Next, we have the total factored live load listed, so that's that 720 in pounds a linear foot in this case. And then finally, we have the total factored composite dead load in this case, and that's that 113. Finally, followed by the total number of shear studs on this particular member. And then obviously we have listed our reactions in this case. So I've got our reactions. We can also go ahead and look at the detailed report. So let's go ahead and look at one of the detailed reports over here where we've got our point load applied. So I'm going to click details and let's just grab, let's grab this one here. And so I'll expand our detailed report. And so here we can see we have that same shape group. I'm going to go ahead and give us, let's give us a load that would show that live load point load there. So we're inclusive of those point loads in this particular case. We've got our diagrams, our deflection as well. And as we start to scroll down here, we start to see our composite kind of checks, if you will. So we have our composite bending, in this case, 84% composite action or composite bending in this case. And so we can see the information about the concrete and then our stud information. So our stud strength, the number of studs and the spacing of those studs. We also have the composite section properties. Then again, this is output that was specifically specified by the SJI as what they would want engineers to put on their drawings and then be able to give to the SJI joist manufacturer. So in this case, we have the size of the bottom chord, the angle size of the bottom chord, as well as the top chord in this case. We have the bridging design, so the spacing of those bridging lines and the number of bridging lines here. The joist seat depth, the joist self-weight, and then just some basics about the deflections, specifically the live load deflections in this case. And now this mentions here again that all the values shown here, other than the CJ designation and span, are preliminary, and you really need to work with your local joist manufacturer to make sure that these are finalized when you go ahead and send these to the job site. And so we've got this report. The other thing that we can open up here is our material takeoff. So again, I only have the excluded members, so I'm only looking at these elements. So in this, the material takeoff isn't inclusive of any of the other concrete or steel or cold form steel elements. And so in this case, we can see our steel joist material, the size, the number of pieces of that size, the total length and the total weight. Obviously, we have a total steel product summation. And then we also have our total number of studs. So a 1.5 inch high times 3/4 inch diameter studs, number of pieces, and we have that information that we can include in our material takeoff. Now, I'm going to go ahead and re-enable everything here. And so let's go ahead and turn off our load. Now we have our analysis done. Now let's go ahead and transfer this RISA floor model then into RISA 3D. So I'm going to go ahead up into our director and choose RISA 3D. I'm using the director, so it's just asking me to save the file, so that's fine. Let's save the file. And then again, I'm going to go ahead, just standard, choose wind load. So we'll choose our wind load here. So we're going to get, our force in the X and the force in the Z direction. And then we'll go ahead and set our seismic load parameters as well. So we'll get, again, our force in the X and the force in the Z direction, as well as our base shear. And then we'll go ahead and launch into RISA 3D version 19. So this is automatically launching into RISA 3D. And then it's just, during this time, it's just reading the file. So it's just kind of checking everything at the file. Obviously, you can see up here in the top here that we now have a notation that this model is a RISA 3D model that has actually come from RISA Floor. So we have that, that denotation. And so now with the model here, we can see our lateral model, and I'll go ahead and turn on our diaphragms. So we have our 2 rigid diaphragms at this case. We can go ahead and also turn on some of our loading. So in this case, looking at our dead loading, or let's go ahead, look at some of our wind loading applied as point loads at this case. And so we have all this information now. We can go ahead and run the design for our, our lateral loading here. So if I look at load combinations, I do already have some load combinations created for us here. So I've already created our wind and seismic load combinations. I'm going to go ahead really quickly and just run our solution for this. So we'll just do a batch solution here. Again, because we're using RISA 3D, it's going ahead and it's using the different cores of my machine to just kind of walk through the combinations really quickly there. So we've got our results. And so now we can go ahead and look at the output. So for instance, if I bring up this concrete wall here, we can see that we're using ACI 31819, and we can come into the different levels of our wall, maybe look at our different regions, and then within our different regions, looking at our cross-section detailing. This output, this detailed output, has not changed since version 18, but now is inclusive of ACI 31819. Additionally, we can go ahead and look at our results for our cold form wall. So if we look at our results for one of our cold form panels, we can see our shear stud panel design, our cord design, our stud design, and then ultimately our deflection criteria, and then our cross-section detailing. So we can see that cross-section information that's being defined for each individual region in this case. So in this case, we're looking at that specific region to design this particular detailed report. And so this is inclusive of all the information of both the lateral and the gravity loads that you have in this particular model. Okay, so I'm really quickly going to transition to using a different model. I know that not everybody that uses RISA 3D or uses our products is doing building design. So I'm going to go ahead and jump really quickly to open another file. So I'm just going to navigate to the desktop here and open this kind of more industrial file, if you will. This is a file that I started in RISA 3D, so it's not in this case linked to RISA Floor. And so if I go ahead and look at it here, we just basically have maybe a pipe rack model, industrial model with some different wings of this particular rack. And so let's go ahead and look at this to, as we transfer into RISA Foundation and RISAConnection as well. And so the first thing I'm going to do is open up our basic load cases. And so in this particular case, obviously I don't have 100 different other load conditions. I don't have that big of a model in this case, but just wanted to show you that here is where we can add all of those different additional other load cases. And so I've added, just some random ones here with some random nodal loads. And so you can add all of those additional load cases or categories as you want. The next thing I'm going to do though is I'm going to go ahead and select just this end frame here, and I'm going to do a dim lock. And as I do that, I want to just select these beams in this part of the frame. And so if I get those properties of these beams, I can come into my releases and my release conditions, and I can see our Simpson strong tie release conditions. And so here, if I use our Simpson yield length, we can see that right now it's showing a various. So let's just, because it's showing various because we have different member sizes here. So let's just grab one member, for instance. So this is going to be a W24 by 104. And so if I enable the yield link, it'll actually calculate that property based on the size of the yield link here and the size of the member that it's connected to. And so in this particular case, if you're not familiar with the yield link, the Simpson yield link moment connections are basically just a prefabricated moment connection that's developed by Simpson. In this case, this designation stands for this yield link, obviously YL. The number 4 here is the stem thickness of the yield link listed in 1/8 of an inch. So that's actually a 1/2 inch stem thickness or web thickness in that case. Then the next number, this 2.25, is actually the width of the yield length, the flange there in inches. And then obviously the stiffness is calculated automatically. And so if we were using this, we could go ahead and enable these yield lengths, and then this would be used as basically a partial fixity end release to do our design and would be included in our output. In this particular case, I'm just going to go ahead and keep these, just going to cancel out. I'm just going to keep these as fixed conditions for this particular model. Now, the next thing I want to do, though, is I want to go ahead and do a quick dynamic analysis. So let's bring everything back here. And if I go back to my Home tab and choose Solve here, I want to solve the dynamics. And so I'm just going to do a quick modal solution. I have just a mass, basically self-weight of the structure. I'm just going to do a quick modal solution for the response vector analysis. So this is just our, we have our participation that we need, in this case, almost 95%, almost 94% in the X and the Z directions. So we have the appropriate participation we need. So that's great. That's exactly what we're looking for. And so now I can go ahead with that and look at my load combinations. I can go ahead and run my analysis such that I get my SX and SZ, loads into my load combinations, so then I can transfer those into RISA Foundation, which is another one of the new features that we mentioned. So I'm going to go ahead and click solve here, and I want to solve the batch solution of all the marked combinations. So again, just really quickly run through these solutions. We ignoring P delta in this particular case. We just didn't have P delta for that mass combination, which is okay. Everything else has P delta enabled. And so now we have our dynamics that we can go ahead and transfer into RISA Foundation. So I'm going to again use the director and choose RISA Foundation. Again, file save, that's fine. We'll go ahead and then pop open RISA Foundation again. And so it's going to read that input file. So here, I already have some of the foundations defined here. So I've already just kind of defined our spread footings. And in this particular case where our columns were really close together, we kind of created a big combined footing in this case. But when we look at this, we can go ahead and look at our dead load, but also starting to look at our seismic load, not necessarily our seismic load, because we don't have any seismic load that was generated by the seismic load generator or the ELF procedure, but we do have our seismic loads generated by response spectra. So if I look at SX in this case, or SY, we don't have anything because we didn't generate that, but SZ, we have that as well. So we have those seismic provisions from RSA now included on these boundary conditions in RISA Foundation. Now we can also go ahead and create load combinations for these. So again, this is another new feature. If I come in to create load combinations, I'm just going to leave these two serviceability combinations and click to generate our load combos. And let's choose IBC 2018 strength. And so we won't do any wind, maybe. Let's go ahead and do our seismic in this case. So I want X and Z. I want to include RSA, so that's a new feature. I can include the vertical distribution, the redundancy. If I wanted to include overstrength, we could do that as well and include RSA. So we can go ahead and generate that. And we generate our load combinations here. So we can now see that SDS factor and the redundancy factor applied to our particular load categories in this particular case. So now I can go ahead and actually solve the solution. So let's just go ahead and click solve batch. So again, using the cores here, running the solution here, we did a very quick optimization. So obviously some of these dropped in size just based on the load that's applied. We don't have a ton of load applied to this particular structure, so we automatically, optimize these. And again, like we mentioned in RISA Floor, if we wanted to kind of dial in on a very specific set of footings, so maybe I wanted to look at the results of only these footings in this little wing here, I'm going to go ahead and unselect everything and choose to select only these footings and then choose my exclude feature here. And then I can go ahead and click yes. And if we go ahead and start to look at our results, so let's say results here for footing results, now we only see the footing design results for those 14 different slabs, or excuse me, 14 different footings. And so we can include that. So if we go ahead and open everything back up, one of the questions that I just saw pop into the Q&A was just how we define this combined footing. So this combined footing is basically defined as a slab. So it's drawn as a slab, and then these four individual kind of boundary conditions terminate on that slab. You could add a post or a pedestal under these boundary conditions so that they don't just terminate right on that slab. And then basically we're designing this based on a kind of a design strip. So I have a design strip in this Z direction and then a vertical design strip in this X direction. And so if we went ahead and looked at the detail, we can see the detailed results of this kind of combined footing. So essentially it is essentially a mat slab that has all of these different points terminating on it. Now, if we look, we had the exclusion of results. I'm going to go ahead and jump from the director back into RISA 3D. So let's jump back into RISA 3D. Yes, I want to save the changes. That's totally fine. And then from RISA 3D, now we can go ahead and look at kind of the final piece of the puzzle, the final kind of interoperability or final exchange integration in this and go into RISAConnection. And so as soon as the project loads here, we can go ahead and look at exchanging elements with RISAConnection. And so we've got our model, we've got all of our information now. So the next thing we want to do, we're not really focused on looking at any of the connections that are kind of superstructure connections, but we're more interested in this case in looking at the base plate connections. So let's go ahead and look at our connections that are defined. So we can look at our connection rules. So we have some different connection rules defined in this case. So here you can see we have single base plate connections, and then we also have base plate with brace connections defined. And so it's these 1, 2, 3, 4, 5, 6, 7, 8 connections that we're going to go ahead and transfer into RISAConnection. So I'm going to go ahead again to the director, and in this case use RISAConnection. So we'll choose RISAConnection, and we're going to launch RISAConnection. RISAConnection version 12 will open up, and then we'll get 2 different groups here. So we have our groups, our 4 connections that were our base plate with brace. And so if we kind of change our view here a little bit so we can see a bit better, we can see that we've got those 4 base plate with brace connections and our 4 single base plate connections. And so if we go ahead and look at, maybe we'll start with the base plate with brace, we can go ahead and open the group and look at the entirety of the group. And so this group has, you know, a similar base plate size, 24 by 18 base plate with a certain thickness. Now, if I wanted to go ahead and look at one specifically, so maybe we wanted to look at this one, you know, we can see the load applied to this one. Maybe this is the one that we wanted to make some modifications to. So I'm going to go ahead and look at a 2D view. And if I click on the bolts, I can go ahead and look at our bolt layout options. So right now, the standard options that we had previously were a 4-bolt layout, a 6-bolt layout option, but we also have now a custom bolt layout option. So when you do that, it actually numbers the bolts for you. So we can see it, the number 1, the number 2, the number 3, number 4. So the designation of those very individualized bolts. And so now if we go ahead and click on one of those bolts, we're highlighted as the anchor bolt section highlights. And here under anchors, we have our bolt coordinates, basically the ability to open up our custom anchor bolt layout editor. So we now are presented with this new dialog. And so this new dialog really gives us the ability to essentially define just about anything that we want. And so I'm going to go ahead and define some additional anchors in kind of inside the space between the 2 flanges of this particular wide flange. So the first one, I'm going to go ahead and just click on the new anchor button. It inserts, by default, it's just inserting at 0, 0. You can see it's highlighted in red right now, and that means it's kind of got some interaction. It's got some issue with where it's located based on the fact that it's located within the steel. Additionally, if we put it outside, we can see here that 1 or more bolts are outside the base plate. That basically is just warning us, hey, I can't put a base plate in this location because it's not on the extents of the base plate. And so I can go ahead and just drag around based on the location. Right now, I'm snapping to my grid. So I'm showing my grid, and I can go ahead and set the grid increments if I want. So I'm snapping to a 1-inch grid increment. So in this case, I'm going to set this first bolt at Z coordinate 4, Y coordinate -3. I want to go ahead and add in a second bolt. So I added that bolt, and I can come into this table and I can just type as well. So I can say I want this to be 4 and this to be 3. And so now we have those 2 bolts. I could also go ahead, if I made a mistake, I can click undo or redo. I can actually delete a bolt. I'm also going to go ahead and hold control and select bolt number 5 as well. So I have bolts 5 and 6 selected. So now I can group move them together. I can drag them around, or I can do kind of a group mirror or group copy. So in this case, I want to take these bolts and I want to copy them or move them or mirror them to the other side of the web over here. So I'm going to go ahead and say move bolts. And with the move bolts here, we have the ability to replace existing bolts and move or add new bolts. So in this particular case, I'm going to say I want to move these bolts in the -8 Z direction. So that's in this direction here. So here's the positive Z and the positive Y. We're going to go in the negative Z direction. And we're going to go 8. So it's basically just going to be a mirror across this center line of the web here. We want to choose to move only the selected bolts, so we don't want to do everything else. And instead of replacing the bolts, which would just put them over here and delete these ones, we want to add new bolts. So I'm just going to add those bolts, and now we get bolts 7 and 8 on our interface. Now there are a few other features here that are really nice. So we can choose to rotate the bolt layout. So if you selected a bolt, chose to rotate the layout based on an angle, you could do that. You also have some predefined bolt layouts as well. So, you know, a circular template or a rectangular template, a template with a hole, or an edges hole template. So these different templates can be used as a starting point, in that. And so then I can go ahead and click OK, and those will pop up there. And so now if we go ahead and look at this in 3D, we have this section here, right? So we have this section here that we're using for our layout. And if I go ahead and ran the connection here, we might get a failure. So let's look at why we're failing in this case. So let's go ahead into our reports. And so it's actually a gusset plate failure. It has nothing to do with the bolts in this case. So if I wanted to go fix this failure, I can go ahead and look at my right view, and I actually just need to change this so my Whitmore section falls within the bounds of my base plate. The bounds of my gusset plate. And so now I have a passing condition for this particular layout. And so in this case, we can make any changes that we want. It's also nice to be able to save a default. So maybe you have a condition like this with a gusset and an angle that you want this to be your default layout, even though it's a custom layout. We can go ahead and click this Save as Default, so that every time that you come in with this type of connection, this was going to be saved as your default layout. So now we can go ahead and with that, we can go ahead and bring this model back into RISA 3D. Also, just to mention, this is one of the things that was new to version earlier this year. We do have the ability to export to Profis, so you can connect with Hilti Profis to do the anchorage design, the concrete to anchor bolt design for all of those different anchors. Now in this case, I'm just going to go kind of full circle here and export back into RISA 3D. And so if we combine here, we can see, I didn't solve all the connections, but we have some of the connections that are finalized, and then we have that one connection. If we go ahead and look at our connection results, we'll get that one connection result with our passing grade there. Now, one of the other things that's nice is we did add this connection detailed results. So basically, if I wanted to go ahead and look very specifically at a connection, I can click on this connection and jump back into RISA connection with that particular connection. So now I've selected that connection, and I jumped right back into that connection so I could look at it more specifically. Maybe I made an update to the superstructure and I wanted to make a change based on what's happening in the model. We can do that by jumping back into RISA connection in that way. So I know that was pretty quick, but we've really touched on most of the new features of our kind of RISA building suite, whether it's in RISA 3D, RISA Foundation, RISA Connection, or RISA Floor. And so as I go ahead, let me go back to our PowerPoint here and just kind of finish up here. We can now, I know that there's been some questions that have been answered during the presentation by our other engineers here, but this is the time where we can ask some questions and we can pull some questions and answer them live. So let's see, a few that were here, not necessarily in the new features, but there's a question about, can RISA Connection do a base plate with two braces coming into the base plate? Unfortunately not. Currently it's just with a single base plate in either the weak or the strong axis. It can account for additional loading in that weak or strong axis, that other axis, but it cannot be, you cannot include that kind of as a node and give you those additional connections. Let's see. There was a question about using dominant mode to determine the reaction directions. I didn't in this case use dominant mode, but it is possible. That's just a feature that you can enable within the generation of those RSA results. So that's just part of the dynamic results that that you can look at. So we can go ahead and enable that dominant mode to give you those directionalities and give you those proper positive and negative forces as you expect. Let's see, any other questions as we kind of wrap up? Like I mentioned, we do have this is a little prior to the release, so our release is going to happen in just a short little while. So these features are not yet available. Will be available very, very soon. We're just doing the final touches to make sure everything is ready for prime time for all our customers. But we're really excited about the opportunity to share these new features, share the integration with you guys again, and really hope that RISA 3D version 19, as well as RISA Floor 15, RISA Floor Foundation version 13, and RISA Connection version 12.01 will really be releases that you're really excited about, and should hopefully give you a lot of really good features that allow you to do your job more efficiently. And so before we finish here, a couple of questions popped in. Can we calculate floor vibrations? Floor vibrations are available in RISA Floor, but only available for hot rolled steel members and also joists, not yet for composite joists. So there's a question about when a connection fails in RISA connection, how do you iterate the dimensions to get the design which does not fail? There's no button that says update dimensions to passing member. It's just one that, because connections are such an iterative approach, you could change the size of a bolt, or you could change the spacing of the bolts, or the thickness of the plate, or the dimensions of the plate. And so it's up to you to control all the components of the connection to see what gives you a passing check. When you're using RISA connection as standalone, as you make those changes, the reports update automatically, and you can see those in real time. If you're using a model that is connected with either RISA 3D or RISA Floor, you just have to click the button that you would rerun the connection, or rerun the group, or rerun the entire project, and that just takes a second. So let's see. So does RISA 3D design for out-of-plane and in-plane seismic loading for concrete walls? So for concrete walls, it does include both in and out-of-plane loading. You can define those walls as special shear walls and get it to denote whether or not you need boundary conditions. It's not going to design those boundary conditions, but it would tell you whether or not you need those boundary conditions for those walls. Looks like that's about it for the questions. Obviously, if there are other questions, please feel free to reach out to support. Obviously, that's what they're there for, to answer any questions you have about the software, about how the software is used. If you're interested in maybe you're a new customer, or you're looking at new products, if you're interested in what we call a software tour, basically a kind of personalized one-on-one or one-on a group, with your office, personalized tour of either RISA 3D or all the softwares together. There's a form right on the website, on the front page of the website, that says you can just apply for or reach out to request a software tour. Those go to me, and our team will go ahead and set those up for you over Zoom. Other than that, we thank you so much for your interest in our new releases of RISA 3D, RISA Foundation, RISA Floor, and RISAConnection. We hope that if you have any other questions, you let us know. If you missed this, or missed part of it, or if one of your colleagues missed part of it, the video will be on YouTube for free viewing in the next couple days. So just give us a few days to get it on YouTube, but it'll be there for your review. Other than that, thank you so much for joining us, and we look forward to speaking with you and working with you in the near future. Thanks very much.